we have a coordinate vector and also we have a coordinate matrix. What was asked in the question was a coordinate vector, not a matrix. And most of you gave a matrix. You see, right? This is what we're looking for. The solution was supposed to be like this. And again, I said that there are differences in brackets, guys. I said that these ones, they are for a coordinate vector, and these ones are for a coordinate matrix. This does not exist. This, let me show you. This doesn't, there's no such a thing. You see, right now, you can't use open brackets here and then here use a square brackets. It's impossible. If you use open brackets there, it means that here you must have this. You see, right? Then if you use closed brackets, it means that here you must have this. And this one doesn't have commas. You're just gonna put your numbers there. You see. So you must be careful how you answer your questions. Check, am I looking for a coordinate matrix or am I looking for a coordinate vector? Then when we come to a transition matrix is made out of the coordinate matrix. You see, right? The transition matrix is going to be made out of the coordinate matrix, which are gonna be placed in order. So we'll see that when we come to do, I think it's number 3. And then for the change of bases, remember I said that you can find this if you're given u with related to c. You see, right now, the vector of u related to c, the coordinate vector of u related to c, and also if you have this p. Remember, p is a transition matrix from C to B. As long as you have C here, it's from C to B. That is our P. You see, right? Now, here's what we're going to be doing. Yeah, I'm not going to discuss the key properties now. We've already discussed this in class. So let me just come to the, let me see, the unique matrix property. Okay, let's look at this. They say that a transition matrix property, if P is the transition matrix from C to B, then this formula we know, right? From C to B, you see, right? Now, if we have this formula, for us to find this, or sometimes let's say they give us this, let's say they give us, sometimes they can give you this one, they give you this, and they give it, let's say they give you this and P. And P, and you must find u related to C. For you to find u related to C, you must make u related to C subject to the formula. But you need to know how do I make it subject to the formula, right? We're not going to divide anything. We're just going to introduce, since P is on the left hand side, we're going to introduce then the inverse of P on the left hand side. If I also introduce it here, then this will cancel out. I'll be left with this formula. You see, right? Now you know why are we having P like that. Now, also we have the uniqueness theorem, which says that if S is a basis of V, then every vector in V has a unique representation as a linear combination of the vectors in S. So this is what we talk about. This is when we talk about the coordinate vectors. If S is a basis of V, and I come here and pick some vector, let's say V, to be an element of V, it means that I can find VS. In other words, I'm representing this V as a linear combination of everything that is in S, and so on. You see, right? So this is what the unique theorem is saying. So all these will be applied in the application. So this is everything that we are applying. Now let's look at this. Well, I did put some verification methods here, and we say that to find the coordinate vector, we express the vector as a linear combination of these basis vectors, right? Then we set up a system of equations by equating components. Then we solve the scalars either by using matrix methods or substitutions. With usually we use simultaneous, you see right now. So these two are the same, right? You do them the same way. Then here they say write each vector in a new basis as a linear combination of the old basis, the same thing. Then we form the coordinate matrices of the new basis relative to the old basis. then construct P with these coordinate matrices as columns. So this and the coordinate matrix, we do the same thing. The only difference is how do we represent them. You see, right? And then when it comes to the transition matrix, you'll see how do we do it. It depends where are we moving from which basis to which basis. You see, right? So we'll see that. I think we've done this in class. We've done a lot of examples. Then I'm not going to look at the additional notes. I'm not going to look at the examples. Let's just jump straight to those problems. Yeah, but keep in mind that some of these examples, when I was busy typing there, I made some mistakes on some of these. So that I just took them as they are. So I'm expecting you, as you are solving these, you should be able to outline such mistakes. And then they say this now. They say we should determine a coordinate vector, right, of x, meaning they want us to determine this. They want us to find x, which is relative to the standard basis s. They want us to find this, right? Not this. They don't want us to find this. You see, right? So they want the coordinate vector, not the coordinate matrix. So we are going to represent x as a linear combination of these three. You see, right? So let's go and do that. We are going to say that x is equal to a1 plus b, a2 plus c, a3, right? And our x is 2, 1 minus 3, 2, 1 minus 3, which is equal to, and here we have our E1 here. Since this is a standard basis for R3, this is just going to be 1, 0, 0. Our A2 is going to be 0, 1, 0. Then our A3 is going to be 0, 0, 1. Then here we're going to have, remember I said that if this is a standard basis, actually you can just simplify it like this. You're going to have A, B, C. Alright. And you know that your A is equal to 2. Your B is equal to 1, your C is equal to minus 3. So we're going to have that x relative to s is equal to 2, 1, minus 3. Then we get the solution. So this is the correct solution they're looking for. This is a coordinate vector. You see, right? Now let's look at the second question. The second question, they say we should find the coordinate vector of p is equal to 3 minus 2x squared relative to a, which that is the standard basis, right? Meaning that we must find p. Keep in mind, this is not the capital letter P. We don't use capital letters here. Relative to a. They want us to find this. You say, right? Let's go and check. So we're going to take this represented as a standard basis of these ones, as a linear combination of those standard bases. So we say P is equal to A1 plus BX plus C x squared. After this, I'm going to give you some question to try, right? I want to try this other question, remind me. Then this side we have P is 3 minus 2x plus x squared. It's 3 minus 2x plus x squared, which is equal to A plus bx plus c x squared. Let me confirm if it's the correct one. Yeah. So what do? We find our values. A is 3. B is minus 2, C is 1. So this means that P is going to be 3 minus 2, 1. This is our coordinate vector. Remember, this is a coordinate vector, not a coordinate matrix. Also, it's a coordinate vector. It's a coordinate vector. Now let's look at number 3. Number 3, they say that we should find a transition matrix from C to B for R2. So they say from C to B. Okay, let's discuss first what is it that we must find. If they say find a transition matrix from C to B, in other words, they want you to take all the vectors. If we have V1 and V2, then here we have W1 and W2. You see? Or maybe before I say anything, what is it that you know about these guys? What do you think we must do here? If they say we should find a transition matrix from this, then for R3, if we should find the transition matrix from C to B for R3. What do you think that is it that we must do? I believe we should be answering. Get all of us here we wrote. This is what I'm avoiding. That's why I don't want to include the others because you guys wrote. So you should reply according to what you wrote.
We should write the vectors in C in terms of as a linear combination of the vectors in B.
We should write what? The vectors in C
as a linear combination
of the vectors in,
as a linear combination of in B.
Of the vectors in B. So you're saying we should write the vectors in C as a linear combination of the vectors in B. Do we all agree there? Do we agree with that?
Yes.
Yes. So it means that we should write this, meaning that this ones here, we should come here and say that this is A W1 plus B W2, right? Then we equate each to this. Let's say V1, also we have V2, which is also equal to the same thing. You see, right? Then we find the scalars. Meaning if I find those scalars, then our vectors are going to be like this. But here, since we're dealing with a matrix, we're going to find these ones. You see, right now? The other one is B, relative to B. You see, right? So let me show you what I mean there. For those who I think, but I believe that we all know here, and that's because I didn't check some of the work. So what we have there, they say we should find. There we have it's C, which we have 1, 0, and also we have 0, 1. Those are standard bases, right? And then they say we should. They say to a basis. What are the bases for B? The vectors. It's 1, 1, 1 minus 1, right? 1, 1, 1 minus 1. In other words, if you must find a matrix transition from C to B, in other words, I'm going to take everything in C, write it as a linear combination of this one. You see, right? So I'm going to say, here I'm going to say this. I'm going to say 1, 0 is equal to A, there it was 1, 1, plus B 1 minus 1. And then I solve for these values. This is A plus B minus B, which this is A plus B, A minus B. Then we have 1, 0. Then we have that A plus B is equal to 1. And also we have that A minus B is equal to 0. Then here we have that A is equal to B. Then we come and substitute here. If A is equal to B, it means that here we're going to have 2B, which is equal to 1, which implies that B is equal to 1 over 2, which also is equal to A. So we found the first one, which in this case, if I name this V1, it means that this one was going to be written like this. It was V1. So here, as long as I'm looking for a transition matrix, I advise you to use a coordinate matrix. You see right now, V1 relative to B, right? Which would be equals to our A is 1 over 2, our B is 1 over 2. You see right? Now we look at the other one. Let's name the other one V2, right? So this one will just say it's V2. Obviously, you're going to name them there. Say that this is V1, V2, A11. These remain the same, right? They don't change. We only change that vector. Plus B1 minus 1. So this is going to be 0, 1, which is A. Already we know here that this is going to give us A plus B and A minus B, meaning that 0 is equal to A plus B, which implies that A is equal to minus B. Then we get that A minus B is equal to 1, which this will imply that if I plug a minus B here, I'm going to get minus 2B is equal to 1, which implies that B is equal to minus 1 over 2. If B is equal to minus 1 over 2, this implies that A is equal to 1 over 2. Because if I plug minus 1 over 2 here, I'm going to get positive 1 over 2. Meaning we have our V2 B here. If we name this one V2, will be 1 over 2 minus 1 over 2. Meaning that our matrix is going to be P, which is, you see the kind of brackets I use, right? Please make sure we put the first one now, V1, we just put it like that here. Then we take the second one and put it on the second part, second column. Then we get the solution. So that is the solution. We'll say, right? Which is the solution that I sent in the group. I sent that solution earlier on in the group, right? So now we're saying that since we know now that the solution is found in this way, let's look at number 6. On number 6, we are told to find, they say find the transition matrix from B to C. You see, already we know what to do. We know what to find. In other words, you must find A1 relative to C. Again, you are moving from B to C. This is from B. So you're moving from B to C, you see. Then you must also find A2 relative to C. After finding these two, you're just going to put them in a bracket. You give them to be this. You see, right? But let me see. Oh, I'm supposed to be doing number 4, right? I mean, I'm doing number 6. Let me just skip this number 6. I thought it was this number 4. Let's look at number 4. Number 4, they say we must find UB given UC. And remember, we have this formula that you must always keep this in mind. They can confuse you sometimes. Let's say they say to tell you to find a matrix from C to B, right? Transition matrix from C to B. Then they give you this vector. Then they say find this. Sometimes they can trap you, right? You must know this formula. The formula is like this. You see, right? So once we have this formula, if they give you this and they told you to find this first, remember this one is from B. It's not from B, it's from C to B. It's from C to B, this one. You see, right? As long as there's C next to it, you must know that it's from C. It starts at C, then it goes to B. You see, right? That's what you must know, as long as there's C next to it. So if they tell you to find this, sometimes they can tell you, they give you this, they say find this. I showed you how to do it. You're just gonna make this one subject the formula, meaning that you're going to have that U C is equal to, since this is on the left hand side, also this one will be on the left hand side, right? And then B, not B man, U here, U B. You see, right? So this is what you're going to be doing. So let's find UB now. Let's go and find UB. Let's go and find, they say UC is equals to 1, 2, right? UC is equals to 1, 2. Here, really, I should have said these brackets, right? Yeah, I just mistakenly typed that. Don't forget here, I typed these things. So I'm going to be correcting them here. So let's add. So now we remember that our P is equals to 1 over 2, 1 over 2, 1 over 2 minus 1 over 2. And we are given that U C is equals to 1, 2. And they say we must find U. Check here. They want us to find a vector matrix, a coordinate matrix. You say, right? If they say find this coordinate matrix, we are going to do this. We are going to say that UB is equals to P UC. So this is 1, 2. Yeah, this one, let me use square brackets. Say that we're going to be using square brackets, right? Let's normalize using square brackets. So here I said 1, 2, 1 over 2, 1 over 2 minus 1 over 2. Then we're going to multiply by this one. This is 1, 2. We're just gonna change it to a vector matrix. So we're just gonna take this vector, this coordinate vector, and make it a coordinate matrix, right? Now we multiply. So this we know it's going to be 1 over 2 times 1 is 1 over 2, and 1 over 2 times 2 is 1. So 1 over 2 plus 1 is what? 3 over 2, right? Then we check this one. 1 over 2 times 1 is 1 over 2. Then this times this minus 1 over minus 1. So 1 over 2 minus 1 is going to give us minus 1 over 2. So you can check those things. Just use a calculator to check that. So if we have this multiplied by this and this multiplied by this, you see, right? So you can just check what do we get. So we get this solution. Is there anyone who doesn't understand how we multiply here? If you are there, you don't understand how we multiply there, you must let me know. So it means that we can now proceed, right? Now let's say this this was number 4, right? Let's look at number 5. Number 5, they say we should determine the coordinate vector of A relative to this, you see, for M22. So in other words, if they want us to find the coordinate of A, so it means that we must do, what is it that we must do, guys? Let me know here. What is it that we must do here? Must find the coordinate vector of A. What is it that you think we should do here? I'm waiting for you guys to reply. We're on number 5.
I think maybe we should express A vectors as a linear combination of vectors in M22.
Yeah, correct, right? So we should express this as a linear combination of these ones, right? So let's do that. Or what we can say also, we can express this as a linear combination, then we equate them to A. Also, this is another explanation, right? So let's do that, meaning that we must find A is equals to A times this plus B times this plus C times this plus D times this. And always focus on how they gave you these vectors. Look at this now. Remember, sometimes they give you 1 here, they give you 0 here, right? They just change these two sometimes, which is still correct. As long as they gave you the standard basis, it will still be correct. So here our A is going to be here. Now we know A is going to be here, B here, C here, and then D at the end, right? So we're going to express those. Let's go and check. So we're going to have A is equal to, this is number 5, right? A 1 0 0 0, B C, and then D. All right. Then here we're going to have our A was 1201. Let's see that. 1201. And then we have A, B, C, D. If we add all these three, A is gonna come here, B here, C here, and then D here. All right. So we have that A is also 1. B is also 2. Yes?
Yeah, on us. This other time you said that since this is a transition matrix, like you should we shouldn't have A B you should have A at the top, B at the bottom, the way at the position of C. So I don't understand what's happening.
That is what I first explained here. I was like, that one, remember I said that one is based on the basis that they gave you. This is the normal one that we know. Remember, this is the base that we always use, right?
Yes.
And then that one, the question was like this. They had swapped these two. You remember, right, ne?
Oh, okay.
Yeah. So you'll always pay attention to your bases. They can also swap any of these. They can also swap these ones. So always pay attention to your bases.
So.
Yeah. So always pay attention to your bases. Then you'll be fine. Is that fine? So now since we found this, remember they said they want a coordinate vector, right? So it's going to be like this. A is going to be 1, 2, 0, 1. Let me see what is the name of this basis. They said it's number 4, right? Relative to, it's not given a name, so we're just gonna leave it like that. We'll just call it, since it's standard basis, we'll just call it this. It's also fine to say A. It's also fine to say E here. You say right, ne? So if you come and say this, it's wrong. You say right, it's wrong. These brackets and these ones, they don't go hand in hand. So you should always make sure if you use open brackets this side, use open brackets on the right hand side also. Are we fine? So let's come to number 6, the one I was looking at that time. Number 6, they said we must find a transition matrix. Remember, a transition matrix, we have to check where it's coming from and it's going where. So it's from B to C, meaning that we must find A1, C, and A2, C. Then we put this together, we get our P. You say right. This is what we must find. So we're going to this. Let me just copy this. I'll just copy this. B is equal to A1, A2, What is E1 and E2? What is E1 and E2? Guys,
1, 0 and 0, 1.
1, 0 and 0, 1, right?
Yes.
Make sure you reply fast, guys. You wrote this thing. So we're looking for B to C, meaning I should take E1 is equal to A11 plus B12. Then I solve for this. This one is going to be 10 is equal to A plus B2B, which is equal to A plus B, which is A plus 2B. Then we have 1, 0. Then A is equal to A plus B, and A plus 2B is equal to 0, meaning that A is equal to minus 2B. If we come here, 0 is equal to, if I plug minus 2B here, I'm just gonna get minus 2b plus b is minus b, meaning that b is equal to 0. Do you agree here? Is b equal to 0? Oh no, b is not equal to 0, man. Let me see. This one is equal to 1, man. I mistakenly said 0 there. This is equal to 1. If this is 1, b will be equal to negative 1, right? B will be equal to negative 1. And if b is equal to negative 1, what will 1 be equal to? A will be equal to what? 2. Then we get this. It means that our coordinate matrix, which is relative to C, will be equal to 2 minus 1. You see right now? Then let's look at the other one. Now we look at the one for E2. Now when we look at E2, we're going to say E2 is equal to A11 plus B1. You start here, right? So you don't miss marks. Then this one is 0, 1. Then here it's A plus B. Here it's A plus 2B. Then we have 0 is equal to A plus B. And we have A is equal to minus B. And here we have A plus 2B is equal to 1. Now if you plug minus B here, we're going to get that B is equal to 1. And this means that A is equal to minus 1. Do you agree there? So it means that A2 relative to C will be equal to minus 1, 1. Meaning that we can find our P to be, we put the first vector, which is 2 minus 1, then minus 1, 1. Is it fine?
Yeah, it's fine.
Yeah, it's fine. So always make sure, guys, when you put your vectors here, make sure you're putting them. Yes, I saw some, they found the correct value. They found this one to be correct, but when they put it here, they don't get it correct. Some they found this, but when they put it here, they put it in this format, right? Make sure a coordinate matrix, you always put it as it is. That one comes here, this one comes here. You see, right? So I can even say this. You see, they always come as they are. That's the nice part about a coordinate matrix. That's why we always use a coordinate matrix whenever we are solving a transition matrix. So now let's go to number 7. When we come to number 7, they say we should compute U6 given UB. You see, sometimes they say that they'll give you UB. Do you agree with me? But we need to confirm here what is it that we are having. So let's check. Remember, we have this formula. They say we must compute UC. First, we have this formula. Let's check. We have that UB is equal to P UC. Do you agree with me here? We have that UB is equal to, this is the original formula we have. And we know that this is, we know that it's from C to B. We agree right now. But if we are looking for, let's say now this one is no longer from C to B. Let's say we're looking for this. We're having, now we're looking from B to C. And we got it already. So it means that it would be P prime, right? Or P like that. So meaning now I have to take this to the other side. So let's see what we get. So meaning that we're going to get U C is equal to P this UB. You see, right? Meaning that this is this matrix that we just found here. This one is from B to C. Do you see that? This is from B to C. So it means that we are going to say this we are going to come and name the previous one, which is number 6. We're going, instead of naming it a P, we are going to name it this. You see, right? So it means that we're going to use this formula for us to find UC. So let's see, it's number what again? It's number 7. So, and remember this one, I said it was supposed to be like this, right? Because I gave it in this format. So, but we must find this. So it means that we're going to say this is a 1 and 2. UC is 1 and 2. So we're going to say yes.
So like for the P inverse, like could you also do it in a way as like finding like the transition matrix from P to C?
Yeah. I'll do that. Here's what I'll do right now. When we're done with this one, I'll prepare another one where, let's say I tell you to find the matrix, transition matrix from B to C. You see, right? And then the next question I say find from C to B. Then some we're going to use the inverse, the Gauss general elimination, to see if we can transition using that method to another one. You see, right now? Is it fine? Is that what you're asking? You want us to find this, then we'll also find this one, right? Ne?
Yes.
Yeah, we'll do so. Because sometimes they can give you this one without giving the basis. They can give you this one. They say find this. It means that you must come and use this, right? Ne? Must we agree, ne? Yeah, we'll do that as your request. So let's try to solve this. UC is also P inverse UB. And this was what? Was 2, negative 1, negative 1, 1. 2, 1. And then this one was 1, 2. Then this is going to be, now what is it that you think we're going to have here? So when we multiply this, we're going to have what? What did you get there, guys? Oh, it's number what? Oh, it's number 7, right? We got, this is 3 and minus 1, right? Okay, let me do it. 3 and minus, I thought it's 1 and 2. It's 3 and minus 1. You said you got what and what?
5 and negative 2.
5 and negative 2. Let's check. 2 times 3, it's 6. Plus 2 times 1 is what? It's 1. Oh, you were using 2 that time. The reason we got 5, right? Oh yeah, let's use this one instead of that one. Let's use the new one. Then the one down here you get what down here?
Minus 4.
Yeah, down here you get minus 4. Let's check. Minus 3 plus minus 1, it's minus 4, right? Ne? Is it fine?
Yes.
Oh, this is, oh yeah, it's minus 3, it's fine. So you get minus 4. So let's see. Now I realize with some of you, right, you got everything correct, but then when it comes to computation, sometimes you miss a value or you miss a sign, right? So this is what they're looking for. But if they were looking for these guys, if they were looking for you, see, after getting this solution, you should come and say this. I say that UC is equals to 7 minus 4. You say right now, even though you use this approach, you're going to say the answer is this. You say right? Yeah, but since we're looking for that, we're just gonna stop there. So let's look at number 8. So number 8, they say we should determine the coordinate vector of u, then of its v or its u or v or v. They say the coordinate vector of v. They say the coordinate of v relative to c. Meaning, what is it that we should do here? Meaning we should express v as a linear combination of these ones, right? Ne?
Yes.
Yeah, in other words, we should find v, the coordinate vector. Actually, it's not the square bracket since it's a coordinate vector. C. We should find this. Alright. So I'm not gonna find this one. It's simple. You're going to do it. Number 8. Already I've done this. You're going to check number 8. What did you find? Then let's look at number 9, transition matrix from B, C to B. Yeah, let's do this one. So from C to B, a transition matrix from C to B, you remember what you are going to do here. You are going to be looking for 1B, XB, X squared B. Do you agree with me here? Is that what you did here?
Yes.
Yes, right. You first write this as a linear combination, then you equate it to 1, you come and equate it to x, you come and equate it to x squared. So we're going to come and do that. Let's see. Let me copy this first. C is equals to 1x x squared 2b 1 plus x 1 plus x squared. They said we should find the transition matrix. Okay. Surely, since it's a transition matrix, we're going to find this. So we come and find them. So now let's see. Let me put them here. So we have C to B, right? Now we say this, since we're having C to B, we're going to have 1 is equals to A1 plus B1 plus X plus C1 plus X plus X squared, which this is equals to A plus B plus BX plus C plus CX plus CX squared.
Can you hear me?
You're talking to me or it's a phone call?
Oh, yeah. I wanted to ask you, didn't you say when we are writing that we're supposed to write 1 plus 0x squared?
No, when we write a linear combination, guys, we only say those things if, let's say, you are letting, let's say you let a vector to be an element of P2. We are going to say A, let's say A0, A1x plus A2x squared. But when you are equating on the other side, guys, you're just saying A plus this times this plus B times this plus C times that. You see, this is a linear combination, but this is just a vector taken from, you see right now, P2. You see, this one you would let it to be an element of P2. I saw some on test 1 day when they were dealing with a polynomial. Here they were saying A0. If you can try to check your scripts, those who did this, you'll see the subtracted marks. You're supposed to get maybe 4 marks there, then they subtracted. This is not, you're no longer doing linear combination, you're doing other things. You see, right? Linear combination, you just say a scalar times whatever is there, plus a scalar times whatever that is there. You see, right? Do you agree there? And then we say plus cx squared. Now this is a linear combination. Right? Then already this one we know that c is equal to 0 and b plus c is equal to 0, meaning that b is equal to 0 because c is 0. Then we come and say a plus b plus c is equal to 1, meaning that a is equal to 1. Do you agree here? Meaning 1b would be 1, 0, 0. Then this is correct. Now you come and say x. Now you equate x. X would be equal to a times 1. You see, it's a times this vector, b times this vector, c times that vector. This is linear combination. Now, this is going to be, already we know at the end we had a plus b plus c plus b plus cx plus cx squared. I'm just taking this from this. Already the right hand side will remain the same always, and this is equal to x. Now this shows us that c is still 0 and b plus c is equal to 1 because this is x times 1, right? And since c is 0 means that b is equal to 1. Then we come and say a plus b plus c is equal to 0, which is this one. There's no constant that side. And then c is 0, b is 1. So this tells us that since c is 0, b is 1, we're going to have a plus 1 is equal to 0, meaning that a is equal to minus 1. Then we got that x b is equal to minus 1, 1, 0. Do you agree here? Do we agree, guys?
Yes.
Yes.
Yes. So this is what we have. And also I said that, remember guys, I said that this side of 1, it's better if you say 1 plus 0x plus 0x squared. You remember, right, ne? So I'd like us to keep it like this. Now let me just change this. Now you'll know why am I changing it. Did mention this in the class yesterday. And so now you'll know why I was saying this. And this one had x, so I'm just gonna come and remove that x and say 0 plus x plus 0x squared. This is what I said we should do. So now you know why I'm equating this to 0, this to, and so on, right? So now we have this. Now we are saying that since we have this, ask yourself, the last vector will be what? What are we going to have the last vector? Who can tell me the last vector will be what? Who can tell me the values of the last vector? Then we'll confirm them. What will be the values of the last vector?
0 minus 1, 1.
0 minus 1, 1, right? So let's confirm that. So the last vector, let me just copy this. This is just going to be x squared plus 0x plus 0. That is just 0 plus 0x plus x squared, meaning that c is equals to 1, right? And then b plus c is equals to 0. Since c is 1, b would be minus 1, right? And then the last one is a plus b plus c is equals to 0. Since c is 1 and b is minus 1, a is just going to be 0 because b and c will cancel out. So it means that x b is going to be 0 minus 1 1, as they said. So let's check the transition matrix. They say we should find the transition matrix from C to B, right? So we can just name it P. The first coordinates were 1 0 0, 1 0 0, and the second ones were negative 1 1 0, and 1 minus 1 0. Then this is our matrix. Are we fine? So it means that this is what we have, right? This is our transition matrix. So let's see the next question. What are they saying? So let me see if I'm going to do the next question or not. But if it's not, let me see. We're doing number what? Number 8, right? Was it number 9? Yeah, number 9. And then there's a compute PB given PC. Remember, already PB we have. Actually, no. Already PB we know what it is, right? We know the original formula, which is like this. You see, right? We have this. We have found this. This is from C to B. Transition from C to B. We have it. We just found it here from C to B. And then this one we are given the PC. P related to C, right? The coordinates of P related to C we are given. And also we must find this. So you are just going to multiply there. There's nothing new. We have done this. So that I'm gonna skip it. Determine the coordinate vector relative. This one they want you to find the V relative to B. Coordinate vector of already done something like this. Find the transition matrix from C to B. We know how to do that one. Yeah, let me ask, is there anything else that you don't know how to do here, guys? Is there anything we don't know how to do here?
No.
The questions they repeat. You agree, right, ne?
Yes.
Yeah, so you're just gonna look at the rest, guys. If you are not getting some of the things, you're just gonna look at the rest. And then, yeah. So, yeah, you're just gonna look at the rest. So, yeah. So let me just stop the recording here.